A very warm good morning to one and all. I am Najia Nesrin and my teammates are Anjana, Aparna and Devika. We, as a team, is well guided under the mentorship of Vijit sir. We are here to present our topic on base isolation. Let's have a quick glance on our topics. So, this is the overview of our presentation, which includes introduction, literature review, scopes and objectives, base isolation buildings, types of base isolation, suitability, isolator locations, applications, project phase, models, summary, and reference. We had discussed about our topic base isolation in the previous presentation, but let's have a quick glimpse on all that. Base isolation is one of the most widely accepted seismic protection system in earthquake-prone areas. It is a state-of-the-art method in which the structure is separated from the base by introducing a suspension system between the base and the main structure. Thereby, base isolation can reduce the seismic demand of the structure and improve safety of the structure. Next is literature review. These are the journals which we referred for our presentation, which includes effect of base isolation for building structures, base isolation technique, the base isolation system, study of base isolation using friction pendulum bearing system, base isolation in seismic structural design, experimental study of an adaptive base isolation system for buildings. Now, let's check scopes and objectives of our presentation. We have a scope of base isolation in earthquake-prone areas. Our objective is to design a base isolation system and to reduce the damages during an earthquake. Please see the maps shown here, which highlights the earthquake-prone areas. These are some of the examples where base isolation had applied. Now, types of base isolation devices. Base isolation should be a system which is capable of restraining the structure under strong gusts of winds and gravitational pull. There are a few practical isolation mechanisms which are widely used in the field of earthquake engineering, which means that these systems are capable of reducing the seismic demand of the structure. Base isolation devices are mainly classified into two: elastomeric isolators and sliding isolators. In elastomeric isolators, there are natural rubber bearings, low damping rubber bearings, lead rubber bearings, and high damping rubber bearings. And sliding isolators is of two: resilient friction system and friction pendulum system. Elastomeric isolators. They are formed of horizontal layers of natural or synthetic rubber in thin layers bonded between steel plates. These steel plates prevent rubber layer from bulging and give strength to this particular bearing. Here, rubber layer acts as a shock absorber. Plain elastomeric bearings only provide flexibility but no significant damping. So, it will move under service loads. So, as the method used to overcome this deflects, we include lead plug. Low damping rubber bearings. Elastomeric bearings use either natural or synthetic rubber. We know that rubber is relatively solid and soft and can absorb energy. It have low damping effect, usually 2 to 3% of critical damping. Therefore, they are generally used with high damping rubber bearings or lead rubber bearings. They are flexible at all strain levels. Lead rubber bearings. In lead rubber bearing, we have lead plug at its center. It provides rigidity under service load and it will absorb energy of the waves during the strong ground motion. It is used as an energy dissipation mechanism. It has a plastic property as it is capable of deforming many times without loss of strength. This lead core deforms during earthquake by absorbing some energy and then revert to original shape. Now, let's see the second type of base isolation device, isolation system based on sliding. The second most common type of isolation system uses sliding elements between the foundation and base of structure. In this type of isolation system, the sliding displacements are controlled by high tension springs or laminated rubber bearings or by making the sliding surface curved. These mechanisms provide a restoring force to return the structure to its equilibrium position. Isolation system based on sliding can be provided with or without recentering capacity. Friction pendulum system. Friction pendulum system is a sliding isolation system wherein the weight of the structure is supported on spherical sliding surfaces that slide relative to each other when the ground motion exceeds a threshold level. Suitability of base isolation. The structure is fairly jointed with sufficiently high column load. The structure has 2 stories or more. The structure is fairly squat. Base isolation is most effective in structure on stiff soil and structure with low fundamental period, and least effective in structure on soft soil and structure in high fundamental period. Each project must be assessed individually and early in design phase to determine the suitability for seismic isolation. Next, isolator locations. From the figure, we can see where the isolator have to be placed according to the structure. The most common configuration is to install a diaphragm immediately above the isolators. Applications. Base isolation has found numerous applications in modern times, such as retrofitting it in residential buildings, monuments, bridges, etc. It minimizes the need for strengthening measures. Our project phases are topic selection, literature review, analysis, and 3D model. This is the model of lead rubber bearing, which is an isolator that we made using the software AutoCAD 3D. The cross-section and more details about this isolator is in the coming slide. This is the cross-section of lead rubber bearing, which we made using PowerPoint. It is composed of laminated elastomeric bearing pad, top and bottom sealing and connecting plates, and lead plug inserted in the middle of the bearing as shown in the picture. The lead rubber bearing effectively dissipates the inertial force upon the building, extends the building's period of vibration, and decreases the acceleration of the building. The lead plug will slide with laminated rubber during earthquake but convert this energy of movement to heat. Meanwhile, the rubber part will preserve its original shape due to high elasticity. This is a practical and cost-effective choice for seismic isolation. This is our model building with base isolation. We use STAT software to develop our model. As base isolation is applicable in low-rise building, we made a 5-story building of 15-meter height and each story having 3-meter height. Here we provide lead rubber bearing as base isolator, and we discussed about lead rubber bearing in previous slides. Now let's discuss about working of base isolator. Its work is to decouple the structure in such a manner to protect the structure from the shaking ground. By providing base isolation device between building and the ground, we can reduce the level of earthquake forces transmitted to the building. Basic principle of base isolation is to modify the response of the building so that ground can move below the building without transmitting these motions. When earthquake comes, these isolators will not allow the vibration energy to enter inside the building, so that frequency relevant to structural vibration will be filtered out and other frequencies will enter which will not cause any harm to the structure. Thus, we summarize our topic as base isolation can reduce the seismic demand of the structure and improve safety of the structure. We had referred all this for this presentation. So, I would like to end by emphasizing the importance of base isolation. Hope our topic and presentation were useful and informative for all of you. If you have any queries or need more clarifications, please feel free to raise us in comment section. Thank you.